Hey everybody. To help you study for your first assessment, I thought I would send along a practice video showing us how to work out, maybe a slightly longer vector problem. And I wanted to walk you through the process and just remind you of, some of the steps you should be taking when you approach some of these problems. All right, so here's the problem. You walk 2 miles at a direction of 30 degrees south of west. Then you walk 3.5 miles 20 degrees north of west. And then you walk 2.5 miles east. Then you walk 4 miles at 15 degrees east of north. So what direction must you walk after doing all that? What direction must you walk and for how long do you need to go in order to get back to your original starting point? All right, so kind of a long problem. And so if you're just given a word problem, the first thing to do is kind of draw it out. All right, so you want to draw out your coordinate system. So we're drawing out a coordinate system, and we're going to keep the convention that east is positive in the horizontal direction, north is positive in the upwards direction, and then west is negative and south is negative in the y direction. And then we're going to draw our individual vectors, and we're going to give each of our vectors names, and that'll help us keep things straight. So the first vector is, walking 2 miles at an angle of 30 degrees south of west. So we find west, and then we go south from there at 30 degrees, and that's the direction of our first vector, which we'll call A. All right, and then we walk 3.5 miles at an angle of 20 degrees north of west. So we go 20 degrees north of west, and we will go here. And we're drawing each of our vectors from the origin, even though this is a vector addition problem. And if you did the tip to tail method, of course, you'd be starting it here. But for our purposes, it's going to be easier if we kind of draw each of these from the origin, and then we can do the graphical method later if we wanted to. But we want to find each of the components of these vectors, which is going to be helpful to draw each vector from the origin. All right, so we've drawn B there. And then we walk 2.5 miles east, so just along the horizontal axis. Then we walk 4 miles at 15 degrees east of north. So we go to north and we move 15 degrees towards east. And that way we're walking 4 miles that way. All right, so we want to next find the vector components. What is their x component and their y component? And we want to be really, really careful with how the angle is defined. Because that simple formula saying, the x component is the magnitude times cosine theta and the y component is the magnitude times sine theta, that's only if the angle is defined as going counterclockwise from the x-axis. So if your angle is defined from a different axis and a different location, you want to be careful. And you go through, SOHCAHTOA in your head to make sure you're applying the right trigonometric function. And one helpful tool for remembering this is that if your vector is in this quadrant, both the I component and the J component should be positive, right? The X and the Y component should be positive. And if you're in this quadrant, the I component should be negative, the J component should be positive. In this quadrant, the I component should be negative and the J component should be negative. And over here, of course, the I component is positive, but the J component is negative. All right, so let's go through and see if we can write down some of our vector components. So we'll write down vector A. So where is vector A going to be? So vector A is right here. So if we look at this, that's going to be like the y component of A, and this is going to be the x component of A, which you can see is adjacent to the 30 degrees. But we're moving in the negative direction, so you can be sure that it's going to be negative in the end. So that's going to be negative magnitude of A times cosine of 30 degrees. All right, and as we said, the y component is opposite of that 30 degrees, so we know we're supposed to use sine, and we're in the negative quadrant, so the j component is also going to be negative times sine of 30 degrees. Oh, so that's the I component. This is the j component. All right, so we've got that. Both our I component and j components are negative because we're in that quadrant. Now let's look at B. All right, so B, again, the x component of B is going to be negative, and it's adjacent to that 20-degree angle. So we're going to say the x component is negative B times cosine of 20 degrees times I, unit vector I. But now our y component is going to be positive since we're moving up or moving north. And so that's going to be times positive of the sine of 20 degrees times j. All right. How about C? Well, C is going to be a simple one. We're moving completely in the east direction, at an angle of 0 degrees from east, so it's going to be moving completely in the east direction. So the C vector is going to be magnitude C times the unit vector I plus, 0 times unit vector j, right? There is no vertical component for that vector. And D, here, we're doing something a little different because we're defining the angle from the vertical line, the degrees east of north. So again, apply SOHCAHTOA. If you sketch out this line here, that you can see that's going to be the x component. And you can see that the x component in this case is opposite of that 15-degree angle. And you can tell it's going to be positive because it's in the positive quadrant. So this is going to be, D is going to be magnitude D times the sine of 15 degrees is the I component. And as you can see here, the y component is now adjacent to the 15-degree angle. So it's going to be the magnitude, of D times cosine of 15 degrees times j. All right, so since we're kind of subsequently walking each of these vectors, and we want to know where we end up before we have to turn around, we would want to add up all these vectors. So first, let's just plug in our numbers and do our calculations. And it's going to end up being negative 1.73 miles in the I direction. Sorry, I'm dropping my units here, but let's remember to add them back at the end. Minus 1j. And B is going to end up being negative 3.29 I plus 1.2 j. C is going to be 2.5 miles in the positive I direction. And D is going to end up being 1.04 I plus 3.86 j. So now we can double check. Okay, A, both the x and y components should be negative. Right, okay, they are. All right. B, I should be negative and J should be positive. So I is negative, J is positive. We're looking good. D, both should be positive. All right, so we double checked that, our vector components have the right sign given the quadrant that they're in. All right, so now since we're walking each of these vectors, first we walk A and then we walk B, and we walk C and then we walk D. So maybe we would end up like somewhere over here, you can kind of imagine. What we do is we add up those vector components, right? So we add up all of the I components and we add up all of the J components. And that would give us if we had originally had walked from where we were to there, right? So let's call a new vector. Let's call this vector E is defined as A plus B plus C plus D, right? And to get those vector components, we simply add them all the like components together. Okay, and that's in the end going to give us 1.48 miles in the I direction, and plus 4.06 miles in the J direction. All right, so the question, keep in mind what the question is asking. What direction should you walk to get back to your starting point? So actually, if we add up all those vectors, it kind of takes us to a point away, and if we add them all up, that would be this vector here, moving to that point. What we want to do is we want to go in the opposite direction. So what we really want is negative E. So negative E is just going to reverse each of those vector components, right? Instead of walking 1.48 miles west, we have to walk 1.48 miles east to get back to where we are. So it'll be positive 1.48 miles in the I direction. And we have to walk south instead. So we have to go negative 4.06 miles in the J direction. Okay, now it's asking us, what's the magnitude? How far do we need to walk? And we can draw this out. So remember, we're gonna draw this out now. So we're kind of going, all right, if this is 1.48 miles and this is 4.06 miles to the south, so how do we get that distance, the distance of the hypotenuse? You guessed it, we just do Pythagorean's theorem, right? The magnitude of E is just going to be the square root of 1.48 miles squared plus negative 4.06 miles squared. And the negative cancels out when it's squared. And the magnitude is going to end up being 4.32 miles. So have we finished the question? Well, not quite yet, because it's asking what direction we need to walk. So we want to think about this triangle again. It's asking us kind of what angle are we walking? So if we're here, what angle do we need to walk? What's that angle? Well, you can use tangent, right? Tangent is going to be opposite over adjacent. So tangent theta is going to equal, so you can take that as a negative, What I recommend when you're using tangent to find the angle is to just make both the values positive, and I'll talk about why in just a second. So it'll be 4.06 opposite over adjacent 1.48. So theta is going to be the arctan of 4.06 divided by 1.48, which gives us in degrees 70 degrees. Now, have we fully solved the problem? So if I told you to walk at a direction of 70 degrees, would you know what I was talking about? You might have to guess what direction I was referring to because you don't know what this angle is referencing. So we have to go back and look at our graph, right? We're going 1.4 miles east and then 4.06 miles south. This is moving in the south direction, and that's moving in the east direction. So what this angle is it's 70 degrees south of east. So we can write down our final answer that to get back to our spot, we need to walk 4.32 miles at 70 degrees south of east. And now we've fully solved our problem. And, you know, it took a little while to get there, right? And so remember the steps when you're approaching a problem like this, right? First, you're going to draw it out. Label your individual vectors, and especially just be careful with the angle that you're applying the right trig law. Because the angle isn't always going to be defined from the horizontal axis. Sometimes it's defined from the vertical axis. And to make sure your vector components are correct, you know, keep in mind that what quadrant is your vector pointing towards, right? And so you can double check your vector components have the right sign. And then adding up the vectors, that part's simple enough. It's just addition. Adding the I components and the j components together, finding the magnitude, that's just using Pythagorean's theorem, right? And finding the angle, we use tangent. And the reason we made both these values positive here is because we're interested in what this angle is. And so that's like if you flip this triangle over, we're really interested in like the magnitudes. That'd be still the 1.08. And this would be 4.06. We're interested in the magnitudes to tell us what the angle of the triangle is. If we had this value be negative, we would have given us theta as negative, and that's a little confusing. Okay, so yeah, when you're using tangent, I would recommend keeping the sides of your triangles positive and then just figuring out which direction the angle is coming from. In this case, the angle is going south from the eastward direction. All right, hope that helps, and good luck.